Who would have thought that pumping could be so much effort?
Oh, I didn't see you there. Today's video is going to be about how to make rocket engines, specifically how to make rocket engines that use air as the oxidizer. From an engineer's perspective, I think it's really important that I don't skip over the failures I had whilst making these rocket engines, because I did have failures. Everyone has failures. But that's what I'm going to do. I'm going to skip over those failures because they're boring as shit.
Okay, let's take a look at the first rocket engine I designed. Notice that I had to stick the igniter in the rocket nozzle itself to ignite the gas initially. This is an issue I fixed in later engines. As more and more propane and oxygen flow through the engine, the nozzle will heat up. Since it's made out of aluminium, the aluminium itself will react with the oxygen, which creates this orange glow. In order to prevent holes from burning through the nozzle, it had to be soaked in water before I fired up the engine, which is not ideal. So here's the next version of the rocket engine. Notice that I've replaced the aluminium nozzle with a steel pipe, which should help avoid the burning issue. As was just demonstrated, the main problem with this design is that the rocket engine can go out. This is because the flame front travels outside the nozzle. The aluminium engine did not have this issue because it had a wider cross-sectional area, meaning the flame front stayed within the nozzle, but here that's not the case. In this section of the video, it appears that the exit flow is quite turbulent, but in fact this is due to the wind direction. The wind is pushing the exhaust gases back onto the engine, which makes it appear turbulent. The gas flow is actually fairly smooth.
Some of the nerds out there will be going, it's an orange flame, it's not as hot as a blue flame. Well, yes, that is true, but I added a secret ingredient. Just search for bacon curing powder on Amazon. You won't be disappointed. Some of you may be having concerns about the legality of adding bacon curing powder to my rocket engines. Well, you're wrong, because I looked up and I can do it. It's perfectly legal. Maybe it's bending a few laws, but shh. But what are the dangers of adding bacon curing powder, I hear you ask? Well, let's ask Dr. Sam. Well, according to Google, bacon curing powder can irritate the nose and throat, causing sneezing and coughing. High levels can interfere with the ability of the blood to carry oxygen, causing headache, fatigue, and dizziness. Sounds pretty good to me. Also, don't forget to wear gloves. Thanks, Dr. Sam. Don't worry, I won't wear gloves. As boring as it may be, I think it's important that I explain how my rocket engine works, so let's get to it.
This is the setup I used. At the start of each cycle, air is pumped from the hand pump into the bottle, where it stagnates, creating a region of high pressure. This high pressure feeds oxygen into the combustion chamber and also maintains the pressure, ensuring that the flame does not travel backwards. Gas is constantly flowing from the can into the combustion chamber, where it reacts with the oxygen. The temperature in the chamber is around 1100 Kelvin, so not too hot. Once the gas is ignited, it is passed over a layer of bacon curing powder and through a throat, generating thrust.
To finish this video off, let's have a montage to show just how f***ing powerful this rocket engine is.